Welcome. In today's video, we will solve the exercises 10 to 14 from chapter 2 from the book Contemporary Abstract Algebra 10th edition by Joseph A. Gallian. So question number 10 is list the elements of unitary group under multiplication modulo 20 and find the inverse of each element. The easiest way is to construct the Calais table. Okay, what is the unitary group under multiplication modulo 20? It consists of those integer which are relatively prime to 20 and less than 20. And those integers are 1, 3, 7, 9, 11, 13, 17, and 19. 5 and 15 are not included in this list because the GCD of 5 and 20 is 5. So 5 and 20 are not relatively prime, and similar is the argument for 15. So we construct the table and the Calais table is we just have to multiply and take the modulo under 20. So the table will be we can find this by simple multiplication and taking the congruence modulo 20. Okay. And in the next row, it will be 17, 11, 19, and 13. And in the next row, it will be 7, 3, 1, 19, 13. Okay, 9 into 13 is 91, and it will be 11, sorry. 9 into 13, 117, 117, it is 17. And the next row is and the last row is 17, 13, 11, 9, 7, 3 and 1. Okay, now it is very easy to find the inverse of each element from the Calais table. The inverse of 1 is itself because here it is 1. And for 3, we can see that whenever we are multiplying this 3 with 7, we get 1. So 3 inverse is 7 and 7 inverse is 3. Now we are going to find the inverse of 9. Okay. We see that whenever we are multiplying 9 with 9, we get this one. So the inverse of 9 is 9 itself. And for 11, we are saying that whenever we are multiplying 11 with 11, we get this identity element. So inverse of 11 is 11 itself. And now for 13, we are getting this 1 here. Whenever we are multiplying this 13 with 17, we are getting 1. Okay, I explain this. When we multiply 13 with 17, what we are getting is 221. Okay, and that is congruent to 1 mod 20. Okay, so the inverse of 13 is 17 and inverse of 17 is 13, and this one is here in the row of 19. We are multiplying 19 with 19, we get 1. So inverse of 19 is 19. Okay. The next question is question 11. For group elements A, B, C, provide a descriptive name for the property A, B, C inverse is equal to C inverse, B inverse, A inverse. And the descriptive name is inverse of product equals the product of inverses in reverse order. This is the descriptive name. Okay. Next question, number 12. Give two reasons why the set of odd integer under addition is not a group. Let A is equal to set of all odd integers plus minus 1, plus minus 3, plus minus 5, and so on. We see that 7 and 9 belongs to A, but 7 plus 9, which is actually 16, 16 is an even integer that does not belong to A. The first reason is A set of all odd integers is not closed under addition. And the second reason is 0, which is additive identity. This also does not belong to A. Additive identity is not in A. Okay, we move toward question number 13. The question 13 is show that the set 1, 2, 3 under multiplication modulo 4 is not a group, but the set 1, 2, 3, 4 under multiplication modulo 5 is a group. Solution. First, we have to discuss this set under multiplication modulo 4. This is not closed under multiplication modulo 4 because 2 times 2, which is equal to 4, is congruent to 0 mod 4, and 0 does not belongs to this set. So this set is not group. Now we move toward the next set, which is 1, 2, 3, and 4 under multiplication modulo 5. We make the Calais table for this group 1, 2, 3, 4, 1, 2, 3, and 4. Whenever we are multiplying these elements and taking the modulus under modulo 5, multiplication modulo 5, we see that this table is fulfilling the all four axioms of group. So this implies that this set is group under multiplication modulo 5. Question 14. Show that general linear group of 2 cross 2 matrices when entries are from the real set, from the set of real numbers, is non-abelian by exhibiting a pair of matrices A, B belong to general linear group of 2 cross 2 matrix from set of real numbers such that AB is not equal to BA. And the solution is we have already done in question number 3, part D. So you people can see question 3, part D. So that's all about this video, this lecture. If the video is interesting, please subscribe the channel and like the video.